Hello to everyone. This is Vishal, and hope all are doing good. And as we are working with animation tutorials in the Kotlin and the Google Map also, so both the sequences going on. Now today we are working with Google Map with such kind of animations. How you can work. That is the second part of the Google Map tutorial in Kotlin. So it's a great achievement for me whenever I read your good commands and your good queries. I feel a kind of proud that whatever I have done for you, you are learning from that and you appreciate it. Thank you so much for that. And in the future, I will upload more good videos for you so you can continue with your queries, and time to time I will give you the responses for that. Okay, so as we discussed last time that what we have done in the Google Map Kotlin, so and Android animations. So let's talk about that first. Okay, so first simply go through what we have done in last animation tutorials. We have learned the simple animations, scroll up, scroll down, rotations, fade in, fade out, and bitmap sequences. So a lot of stuffs we have worked. As today session be going on with this animation to your Google Map. So in my Google Map animation series, on the first we have learned how you can make a custom marker and how you created a polylines if you learn from that. So today we are working with the GPS again, and how you can do the animation, a simple car animation, the basic steps of on that. So we have to learn. So marker indicates single locations on the map. You can customize your markers by changing the default color or replacing the marker icon. So these kind of stuffs we have learned how you can make your custom marker. That means at that time I put it the car instead of that marker. So first you have to learn that tutorials and come on this. So today we have to learn that how you can move that car on the Google Map on polylines. So we have a lot of stuffs be there, just like Google Map, how you can put the car, how you can on the map ready, how you can use the marker options, what are the polylines, so basic things, and how you can generate the polylines. So that means these kind of stuff. So today we have to work with animations between 2 points of lat longs and rotate the car animations on that polyline. So here we have to work with the interpolation, so that is the most important. Meanwhile, I will describe to you how you can work with that interpolation. So just simply interpolation is a way to find the values between the pair of data points. So here if we have a two lat longs and we have to calculate that path and we have to run that animation on that path. So that's simple. Here on a simple language, this is called here interpolation. So interpolator comes into the picture between animation time interval to help changes the mapping of a frame to time instance. Okay, so in a basics of the interpolator I will describe you in my other sessions, but today you have to learn that. That means we have to create a simple animation between two lat longs and you have to rotate that car on that particular motion. So this is a very basic steps you have to learn today. So let's start it in Android Studio and we have to work on that. Okay, so let's check in Android Studio what we have done last time. That we have a simple map fragment and on which we have created uh, lat longs, and on that we have put it some polylines using the polyline options, and also we have worked with a custom marker using the resize bitmap, and there we put it a car marker uh, that is by name in travel and with the width and height. So those who don't know about this, first learn from my first tutorial and then learn also the animation parts. So that is a sequence of 3 or 4 in a Kotlin. So you have to go for a first Kotlin Google Map animation. I provide you the link below. So first you have to learn from that how you can use your custom marker, how you created the polylines, and now we have to work with animation. So for this animation I don't want to go with the multiple. At this time I will describe you my first point because of very basics. I'm taking 2 points here for the lat long, so you learn perfectly how you build your own methods. First you create your own method and just learn the basic things, then we go for the value animators and other animators and default rotations, all these kind of functions how Android provide to you. So this is the way we can work. So first we have to go with interface. That means we have to start that car in as an animation on Google Map. So the first basic thing is here you have to create a interface so we can check the difference between these two points and then move the car on that 2 points of the lat long. So here we have an interface, how you can build the interface in a Kotlin. I'm giving the name as a lat long interpolator, and under that interpolator we have to use a function interpolate. Here we need a kind of fraction. That fraction works with timings, that means from start point to whatever be the last point, okay, for the polyline. So that means whenever you work with the interpolations, that means we have a kind of distance calculations with the timings, and you have to run that particular values on that 2 points. So we have multiple interpolations. I will describe you one by one on my next tutorial in coming sessions, in which you can learn how we can go in the depth. And also I describe you the linear interpolations in my previous tutorials. You learn from that. Okay, so here we need a first point, first lat long, and we need a second lat long. So that is your A and B point. Okay, and then we have to return the things is in a as in a lat long, because of we have to pass that method values b as in a lat long. So here we have to create a class linear. First I am going with the class linear. How you can that work with that linear, that is a straight line, and rotation how works with that. So here we have a lat long interpolator which we have created, and now it says that we have to create a method. So say alt enter and implement methods and interpolate. Okay, so this is the method we have to use. And uh, so whenever you work with that means very basic thing is we have a first point, we have a last point, so we have to calculate calculations with the fraction. So how to do that? You have a val, that is your lat. First we have to calculate the lat or very first point, and I'm using the double. You can use the float also, it depends. And here we have a b dot. Your first we calculate the latitude, that means last point minus first point. So this is your b minus a latitude, multiply with that fraction, and then we have to add our very first point, a dot latitude. Okay, similarly we have to work with the long, and here that long we work with a double, and the same thing we have used, that is your longitude. So here we are working with the longitude, because first we have to calculate latitudes, then we go for the longitude minus a dot longitude, your fraction, and then plus a dot longitude. That means if we have a start point a, we have a fraction something, that means I will describe you how you can work with a fraction in handler, or you can make your own function with the handler. Okay, and that time we have calculate at each and every milliseconds or a second, it depends whatever you want on that, and that calculate the fraction of the timings and put it and change the scene of a car. Okay, so that is the difference we have to calculate and move the car on that. So this is your lat, this is your long, and that's your lat comma long. So we have written this is because of our lat long always be work with the lat comma long. Okay, under that we can return the things and work on. So this is a very simple linear interpolator. Now we have to create a method for animation. This is a basic work how you can work with the handler. So here you use your method animate marker, and that marker be our marker, and that marker we work with the final position, because of we can take our first position be as a marker position, and the final position be that is our last lat long point. Okay, so this is our always be a lat long, and comma you have a lat long interpolator, and that interpolator I am using our linear because of we work with that linear. Okay, so this is the way we can work our simple interface. Then we have a linear class in which we do some calculations, and that calculations we pass from that methods. Okay, so here first we can take our start position, and that start position be our lat long, and that is our marker dot position. Okay, so this is our marker. That means we have start our whatever where we have our marker at this time. From that position to we have to calculate the things on that area. Okay, so here uh, we use a handler that is equals to your handler. That handler be works so similarly same as you work with the Java. And here I am using the start long, that means the calculation of timer. So that means our system timings or system clock works from that point. That means our very first point we have to calculate and have a function with the uptime L. So here we have our interpolator, and I'm using at this time default interpolators, that is accelerator, decelerator, interpolator. And if you want to know about this, so that means whenever you work the speed or any calculations we are using this. I will describe you one by one all the interpolator as I described you in my previous linear interpolator. So that is the difference. You can use a linear interpolator also, but the basic differences we'll discuss on in details in coming sessions. So here you use this simple interpolator, that means it works with speed, nothing else. Okay, and here we have a duration. I'm using duration as an ms millisecond, and I'm using 10,000 f. You can use your own, depend. And here we are using here we have a post post um, okay, object runnable. So here I'm using the object as a runnable. Okay, and that runnable be works. mm, Alt enter, we have to implement the method run. Okay, so here we have some values, that means each and every time, each and every milliseconds we have to calculate. We need some elapsed time where it work. So this is a very simple three or four values we have taken. Simple handler, starting time, start position, interpolator, that means by the speeds. Just simply we have a calculations to points, but here it nothing, it just simple interpolate the things. will describe you. Otherwise you can use simple linear interpolator, not a linear one is our method, linear interpolator. Okay, so here we have where we can use elapsed time. So this is on the long, and here I'm using a simple value for the calculation of a timer, that is the time and speed each and every second or a millisecond, just simple. So what we have to do, we need first calculate the elapsed time, and that elapsed time we work on system handler. So we have a system clock dot uptime is and minus start. Okay, so that's the point we have to work, and t is equals to your elapsed time. Here we have to check the elapses and duration in milliseconds. So each and every calculations of the t be here, and b by depends on t. So here we have a interpolator as an accelerated, uh, so we have got interpolations for that, and we pass that timer be here, that each and every second it speeds be work, that means it changes its position with some speed, and we get a new position on that speed, particular speed. So here we have a lat long, and that is our a simple lat long interpolator, that is our method, and that is interpolate. Now these above fraction we have to pass here. So this fraction is what? It is a v. Okay, each and every time our speed or changes the position, and our um, first position is very start position where our marker at this time, and we have a final position, that means where we our marker will reach. Okay, so that's we have to calculate, but each and every seconds up to that point it works with v, and we have to pass this in a marker. So we can say that the marker dot position is our new position. Very easy. So that's the step. And one more thing, if you work with the handler, you know that if we have a less than one or this kind of stuffs, we just say handler dot delete. So here you can use the post delete, and that delays be this comma, you can put your on time. Okay, so that's the way you can work with the handler. So first we see what be the result, and we can call that function under the button click. So here I'm using a button in which we can play our values. Okay, so here animate marker, so my marker be here comma final position. So I want, this is our start position, 29.69. Let's check. Yes, and we have to reach on 29.64480. So just copy that lat long up to that point, and paste it, and we have to call our class linear. So that's the way, or very simple, you can calculate animate marker. So let's see in Genymotion, so work on that. Okay, so let's check in what happened. Yeah, you can see that here we have a car and we have a poly marker, so lines. So here any line we have sketch on our Google map. Now we have to move car, so you can see that each and every second it changes it, and it move to the last position. Okay, so that means that is we have to work the animate from first point to last point. Now what we have to do, that means because of it's not working well, because we have to move on that particular uh, polyline side, or whatever be our lat long side, it rotate. So we have to make our rotate function also. So let's see how you can create a rotate function with this. Okay, so let's check 2 points we have to bear. So here we have a lat long 1, or whatever be your point A, and that is your lat long. So that means lat long 1 comma lat long 2, and then we have to calculate these two. Okay, so here on the second we have a lat long 2. This is your lat long also, and that lat long we have to return as in a double. So this is the way you can calculate your pairing 2 points. Okay, so here first we need a simple val lat 1, that is our double, and we need first two special methods that we can work degree to radians and radian to degree, because of we need to work on that. So for rotation, first we have to calculate the degree to radians, because of whenever the work calculation we work how much degree we have to rotate. So first we need to check the degree up to 180 or 270 or 60. So that degree we have to rotate according to. Uh, so you can pass your degrees on that methods, and just so this is your, in a future this to be important method. Will describe you in my coming session how much they important. Degree to radians. So whenever you work with the degree to radians, this is our degree, and that degree at this time I'm using the double because of it's our method, and we can return that as in a double. uh, Double. Okay, and here that means we have to return that. So degree, so we have a return degree multiply pi by 100. That is very, sorry, 180.0. So that means simple way you have to work with the degree to radians. Okay, and here we have another method that is called your private fun, and here we have to make it as a radian to degree. So that means degree to radians we have a pi by 180 degree, and radian to degree just opposite to that, radians 180 by pi. Okay, so let's see why it's little bit slow. Just wait for this. Okay, so hmm, here it is radian. Okay, so here you can pass that value be as an radian, and that radian is your double. something wrong with this. Yeah, and that is your double. Okay, so here we have to return and that radian multiply by 180.0 by pi. Okay, so these two methods we have to work. So here first we have to calculate our degree to radian, and here degree to radians we need a lat long, our lat long 1 toward latitude. Okay, so that means first we have to calculate that latitude, then we have to calculate our longitude, and then the same thing for the second one. Okay, so here I am using a long one, and here I am using a longitude. So these to be, and now we have to copy paste and put on. This is your 2, and here I am using 2, and this is a 2, and here I am using 2. Okay, so this is our latitude and longitudes for a 1 and for a 2. Now we have to calculate the distance long. So this is our distance long as a double, and that doubles we work with the long 2 minus long 1. So that means we have to calculate the long 1 long 2 differences. According to that we have to rotate our marker, and here we have a y value, that means the y or x positions. We have to check where we have to rotate because it's our own function, so it's work like that. But if you use a build function for the rotation where we have a get bearing also, you can, that means rotation also for the marker, you can work on that also be. But here I just described to you how a simple method we work. So this is our sign, and under the sign we are using distance long, that means on that we have to calculate our simple y rotation as in a y, and multiply with your math dot cos. So these are the simple calculations if you want to work on that, and this is your math dot cos lat 2. According to 2 we have to, that means whenever you work with the, we have two parts of the cos theta and the sin theta, x-axis rotations, y-axis rotations. So these things if you know about the maths. Okay, so I'm not describing on that details. It's just a very simple way or very simple approach you have to work. Okay, and if you work with the val x, and that is our double also, and that double b works with your math dot cos, and this is your lat 1, and this is your multiply. According to that lat 1 we have to check our position, so this is your math dot sine. This little bit complicated calculation, but you just simply learn how you can, because of if you work with the rotation function, so that is the calculations behind that under the marker, that means marker dot rotation we have. Okay, so here math dot cos lat, math dot sine lat 2, then we have to math dot, it just be the calculations of mathematics dot sine. Here we can say that this is our lat 1, and multiply cos lat 2, just copy paste, and we have to calculate with math dot cos, and here we can use our distance whatever be on distance long it works. That is your x position. We have a calculate distance long with the cos position, and then we have to calculate well radian bearing, and that's also be a double, and that is your a tan 2. It is a very good function of mathematics, a tan 2, yes. And this is our double double, so that means y comma x. So we can run that according to bearing, and here we have written that return bearing. So that is your calculations of radian to degree again at this time, so we can return our values to that. So this is your radian to degree, and here your radian bearing. Okay, so here you can calculate with the two latitude bearing 2 points. So first, whenever you start your animation here on click, we need a rotation first. So I'm just checking that whatever be a bearing. So bearing between 2 points, our first position is this one, this latitude longitude on a start position. Let's check everything is fine, and comma up to this position we have to move. That's easy. So this is our bearing 2 points. Let's see one more time. Everything is fine be here. We have to calculate the lat 1 long 1, lat 2 long 2. Well, calculate the long distance, longitude distance we have to calculate. Then we move on the y rotation, and y rotation methods be your math dot science distance log, and multiply math dot cos latitude 2, and whenever you work with a double we have a cos dot lat 1 multiply by sine lat 2, and math sine lat 1 sine lat 2, and then math dot cos distance long. Okay, fine. So now we have to check on our journey motion, what happened with this. Okay, so let's see what happened with this here. So whenever you move the car you can click, and you can see that it's perfectly work with rotation values. Okay, so that means whenever you can get bearing you can click on, and it rotate according to that. But one more thing that I am using, that whenever this animate marker be bearing 2 points work, you can use my marker dot rotation, because of we have to use that on the bearing 2 points. If you directly call that bearing 2 points, so sometimes it create a issue or it not working. So you can work with according to rotation. That means whenever you rotate you can put that bearing 2 points. So whenever we have a multiple array list you can pass that lat longs, and then first you sketch all the polylines and then use that marker dot rotations according to that on a dynamically. So this is a very basic things you have to work. And one more thing, whenever you use the marker dot rotation you can convert this bearing 2 points into float value. Okay, so this I will upload on GitHub, so you can work with this project. And also you have to work with coming session that I will upload, or for a multiple polylines and multiple path, how you can, until you try that your own, how you can build with that. And also we can work with the value animator. So today that's wind up. Thank you so much for the day, and keep going on your good comments. So I will give you reply on that, and whatever be your queries, time to time I will give response to them. Thanks so much again.